All right, welcome back, everybody. Today we're going to be going over k-nearest neighbors and continue with our introduction to Python because we left off a little bit at the end. And again, we're going to do the introduction to Python at the very end of the workshop. So for those of you who already have experience, already know Python, you guys can leave at that point. Once again, here's the attendance code. If you're watching this live, you can enter it and get some points. The Discord link is here as always. So like if you're watching this, sorry, asynchronously, or if you have just questions after the workshop, then you can ask us on Discord, where there's a dedicated channel just for this workshop, and also other channels if you just want to talk about AI in general. And if you want the link to the slides, you have to go through the feedback form first. The link is here, and oops, yes, Nikhil also put it in the chat, so you guys can click on the link to get the slides. And please fill out the feedback form at the end of the workshop. We take into account all your feedback to try to make these better every time. All right, without further ado, we'll go into our first machine learning topic, which is k-nearest neighbors. K-nearest neighbors, first off, what is it? It's an algorithm where our goal is to classify a new data point based on how its neighbors are classified. So this is one of the simplest supervised machine learning algorithms out there. It's pretty simple because there's really no training involved, and the model itself is actually just the data. And you'll see in a moment what I mean, but we wanted to choose this or show this off in the second workshop because it should be pretty intuitive to understand. If not, then hopefully our explanations will help. And it's actually pretty powerful. You can actually do a lot with it. One thing to note about k-nearest neighbors is that the outputs are discrete. So when we have an example that we want to classify, we choose a certain category, whether it's class A or class B. This is as opposed to regression. I think you can adapt k-nearest neighbors for regression, but we're not going to go into that in this workshop. We're just going to focus on using it for classification. But again, if we're using it for classification, then our outputs are discrete. So in this case, we're classifying whether or not this orange square is either a red star, class A, or a green triangle, class B. Yeah. And so before we get into the details of the algorithm, we're going to talk a little bit about the intuition so that you guys can kind of get a feeling for how it works. And to do that, we're going to go over a quick example. If you guys wanted to figure out the difference between a cat and a dog, what features would you might look at? So you can kind of throw out ideas. And the features I'm kind of looking for are high level. So it's not like looking at specific pixels or the colors, but something more along the lines of like what anatomical features do dogs and cats have? All right. Some people are saying in chat. One person says whiskers. That's right. Another one is ears and tail. Another one's eyes and pupils. Yeah, those are all right. But yeah, those are all right. Good answers. So one thing that we're going to look at is the sharp claws. Cats have sharper claws than dogs because they use them for climbing and grabbing onto prey. They also have shorter ears. One person, I think, mentioned ears. Their ears for cats are generally shorter than dogs, and they also meow instead of bark. On the contrary, dogs have dull claws because they run everywhere, and they don't really use them to grab anything. They also have longer ears than cats, typically, not all dogs, and they bark instead of meow. Right. So how do we use this information to kind of determine the difference between cats and dogs? So one way we can visualize this is to actually plot the sharpness of the claws and the length of the ears on two axes. So on the x-axis, we have the length of the ears, and the sharpness of the claws is on our y-axis. And if we plot each point, is like whether or not, or each point represents one instance. So it's like this is the data for one cat, and this particular cat has this amount of sharpness and this amount of length for their ears. And then this one will be a point for a dog, and so on and so forth. So we plot it all out, we'll get a distribution like this. And you can see that all the cats are kind of grouped together and all the dogs are kind of grouped together. And the cats are grouped separately from the dogs because cats tend to have sharper claws and shorter ears, and dogs tend to have longer ears and shorter claws, or duller claws, not sharp, shorter. So if we wanted to predict whether or not this mystery animal in the middle, ignore the fact that the silhouette looks just like a cat, what would you guys think? What do you think it would fall into? Do you think it's going to be a cat, or do you think it's going to be a dog? And maybe you can answer like, why do you think it's a cat or a dog? Based solely on the information you have here, which is the length of the ears and the sharpness of the claws. What do you guys think? Do you think it's a cat or a dog?
I mean, based on the picture, probably cat, because yes, it's right next to a dog, but it's also right next to 3 cats.
Yeah, that's exactly right. And that's exactly what we're going to look at. Someone else also answered cat in the chat, and you're right. And that's also the intuition that k-nearest neighbors, or that's kind of how k-nearest neighbors works. So we look at the proximity of our unknown animal, and we see that there are more cats near it than there are dogs. And so we predict that it's probably going to be a cat. And now I'm going to hand it off to Nikhil to talk about how k-nearest neighbors actually works, or kind of formalize the intuition I gave you in the example.
Yeah, so let's go back to the example we talked about a bit earlier with the stars and the triangle. So here we have 2 classes. We have class A, which are the red stars, and class B, which are the green triangles. And so in this case, we have a labeled data set. That means that we have a bunch of data points, namely all of those stars and all of those triangles that we already have. And we already know which class they're in. Like, we know all the stars are in class A, and we know all the triangles are in class B. Thus, we have a labeled data set that we can use for k-nearest neighbors. Now, with that data set, we can now get new data points that we don't know anything about. So that question mark in the middle, we actually don't know which class it's part of. Is it a triangle or is it a star? Right now, we don't know. But based on the information that we have from our data set and the new data of the new data point, like namely what its x value is and what its y value is, as you can see on the graph, we can determine what this question mark actually is. Then you got the next thing.
Yeah, it's not advancing for some reason.
Okay.
There we go.
Awesome. Yeah. So now going to the point of k. So you might be wondering, why is it called k-nearest neighbors? Like, what does a k mean? And so actually, in this case, the k is a parameter that you pass in, which basically tells the algorithm how many nearby data members are you looking at to compare. And so as you can see in those 2 circles, we have k equals 3, in which case we're looking at the 3 closest data points. So k equals 3, we have that 1 red star, and we have 2 green triangles. Well, if we make k equals 7, we have 4 red stars and 3 green triangles. And if anyone wants to point out a problem with that, or like a small detail about that, you can feel free to point that out in the chat, but we'll get to that in a second too. But most importantly, we have labeled data set, and we're basically trying to classify an unknown data point based on how close it is to the existing data points in our data set. All right, so quick poll, answer in the chat, or feel free to unmute as well. We have a bunch of points, a bunch of red points and a bunch of blue points, and 1 green point, which you don't know the class for. And so our question to you is, how should we be classifying this green point? Should it be A, red, purple, blue for B, C, purple, or none of them? Feel free to answer. And if anyone wants to unmute or just write it in the chat just to say why, feel free to do that as well. Yep. All right. Thanks to 2 guys people in the chat. Yeah, there's 2 close red ones. So if you guys imagine we draw that same circle around the green point and encompass 3 points. We have 2 red points in that circle and only 1 blue point. So the red point at 3,6 and the red point at 3 point.
Meet up with a random person. The other day I posted on my Instagram that I would be hand delivering merch to a lucky fan.
All right, it's gonna mute Jeffrey. No worries about that. Don't worry about that. So yeah, back to what I was saying. We have the 2 red points near green, and we have the 1 blue point. And so we see that 2 red points is actually more than 1 blue point. Some cool math, and we figure out we classify as red. So you guys are all right. It is a red point, red class. And so now we have to figure out how we classify or how we choose our factor k, because k actually is really important in determining which class our question mark data point ends up going into. And so
it's not oh, there it is.
It's slow. Okay.
Yeah, it's weird today.
I see. Yeah, no worries. I'll just keep talking until it shows up. But
oh, wait, it hasn't showed up for you?
No, it hasn't showed up for me.
Huh. Okay, I'm gonna restart the presentation.
Okay. Yeah. Awesome. Oh, it showed up now. Wow.
Yeah. Okay.
Okay, cool. Yeah. All right. So as we talked about a bit before, kind of vaguely, but now we'll make it more concrete. K and N's are actually based on feature similarity. And so basically, we're seeing how close the features of the question mark data point are to the features of this, the data points around it. So basically, on the graph to the left, we have every data point, whether it's already labeled or not, whether if it's a star, a triangle, or a question mark, has an x value and a y value. And so we're classifying our question mark based on how close it is distance-wise to a couple of points nearby. And so choosing the number k is actually really important because that determines actually how you're going to choose your class. And so actually in this case right here on the left, we have a really important possible problem with different k values. So we see on the left, right, at k equals 3, we have 2 triangles and 1 red star. And so in this case, we'd obviously classify question mark as a green triangle. But if we make k equals 7, now we have 4 red stars and we have 3 green triangles. And now we have 4 is greater than 3, so we have question mark is now a red star. And so you can see how changing the value of k even a little bit can actually change how we classify our question mark point. And so it actually becomes really important how we choose k to get a good classification for our question mark point. And so we're going to dive into how we choose k coming up next slide. Because there's actually a couple different ways to tune it and also pick a good starting point. And so in general, if you pick a k that's really low, so if you pick like, for example, k equals 1, it can be really skewed by outliers. So let's say there's this one cat that has really long or really short claws and has really short ears or something like that. And so maybe our question mark point is actually a dog, but it happens to be next to that cat who's an anomaly, like has short claws for some reason. And so if we had k equals 1, because that cat is closest to the point, we'll end up making it a cat, make the question mark a cat, even though it's actually a dog. And so we don't want a k that's too small. But on the other hand, if you make k really, really big, we're actually doing a lot of computation. So imagine if k is like almost as big as the whole data set, you're calculating distance from the question mark point to a lot of points in this data set. And so if you keep doing this over and over for many different data points, that's a lot of computations over and over again. And so we want to make sure that we pick a k that's not too low, but not too high. And so in general, there's a good rule of thumb that people typically start with to follow is that you end up choosing k is as the square root of n, where n is the number of data points you have in your data set. And so in this case, it would be, what is that, 7 plus 8, 15. That's 16 data points. So you make k would be equal to 4, but we can't have an odd number, even number k, which is actually really important to say too. So if k is even, it's actually a pretty easy to imagine problem. So let's say we pick k equals 4 in this case. Actually, it might not be too bad because I think it'd be 3 green triangles to 1 red star. But let's say there's 2 green triangles next to question mark and 2 red stars next to question mark. If k equals 4, how are we going to decide is question mark a triangle or a square? We can't really. So we need an odd number so we can break ties in classification. And so in general, just choose start with k equals square root of n, and make sure it's an odd value, so either +1 or -1 from if it's even, and then start tuning it based on how good your classification is. And we'll get to the tuning part in a second. And so here's a different way to see it, actually. So in this case, we have 2 different k values on the same data set, and you can see just how different the classification ends up being. And so it's actually, you can see each of the colors, red, blue, and green, as different classes that it's classified as. And so you can see a k equals 1. There's a couple of blue blobs on the right side that are just made of 1 or 2 data points. And because k equals 1, you can have the problem where you have outliers that influence the classification of a point. And so even though the blue point in the bottom left, the bottom right corner should be a red most likely, because there's that one other blue next to it in the bottom right corner, it ends up coming blue. And so we have random spots of blue in the bottom right corner. And so that's the problem with the really low k. And you see, as you make k a bit bigger, make k equals 5, you have more separated regions and that are more clearly classified.
Oh yeah. Also, I don't know if anyone was curious, but the white areas are where there are ties. So like you can see, there's 1, 2, 3. There's an even number of both of them, so they can't classify.
Yeah.
Yeah.
All right. So now let's get to use case. So even though KNNs are really awesome, they have some limitations as well. So you want to use KNNs when you have a complete data set, because let's say you have this data set in this table right here. We have a complete dog. We have a dog's claw length and ear length. We don't have a cat's claw length and ear length. And so it'll not be hard to classify for a cat, because the cat's x coordinate, you can think of it, isn't existing. And so how do you calculate distance when you don't have like a certain coordinate to go off of? So without enough data, without a complete data set, it's really hard to accurately classify things with KNNs. Also, it's really a lot better to use a KNN when the data set is relatively smaller compared to a large data set. And this is because KNNs are looking at relative similarity to other data points. And so last week we talked about training data, machine learning functions, and making them learn to find differences in features. But KNN isn't doing that. It's basically comparing how similar its features are to another cat or dog is. And so because of that, as the data set gets larger and larger, and as you add more classes, it can become a little bit less accurate. And so another quick poll on how to find k. If we have 170 data points in your KNN algorithm, what k value should you pick? 11, 12, 13, or 14? Feel free to put it in chat. And if you're feeling brave, either write an explanation or, oh, slides went down then.
Okay, Zoom just crashed, but it started. But Firefox also crashed. So
yeah, I see a lot of people putting 13 in the chat. So feel free to unmute or just write in chat why you think it's 13 and how you got there. Be awesome. Yep. So yeah, yeah. Two of you guys got it. Yeah, square root of 170 or square root of n is 170 is about 13. That's a base. That's it. And so using that, you can basically figure out it's 13. Also, another way you can think about it is that you could immediately eliminate 12 and 14 because they're even. And so now you're left with 12, 11, and 13. And as you guys said, 13 squared is closer to 170 than 11 squared is. And so we want to start with 13 rather than 11. So yeah, good job, guys. You got the right k value on that. Then you want me to show slides or?
Oh yeah, sorry. Firefox crashed for me, so I'm trying to restart it. You can continue sharing if you want.
Okay. Yeah, I'll do that in the meantime then.
Yeah.
Yeah, 1 second, I'll get it up.
Wait, actually, I got it back.
Oh, you did? Okay.
Oh, no,
Sure.
you got it. Nice.
All right, cool. I'll get back to you when you go to the Python section. Yeah. All right, can you guys all see this? I can't see chat anymore, but you guys write in chat and I'll see. You guys, everyone can tell me.
Yeah.
All right.
Yes.
Cool. Awesome. So now we're going to move on to a case study of like cadence in action on a potential data set. And so, whoops, skip the slide. Okay, good slide. All right. So let's test a cadence on a data set. And so let's say we have a data set of 2 variables, height and weight, and we're trying to classify a person or an animal or something as normal or underweight. And so as you guys can see here, we have 9 data points and we have classifications for all of them. And so we have a labeled data set, so we can start with cadence. And so now, given that data set of 9 points, we want to figure out, is this new member with a weight of 57 kilograms and a height of 170 centimeters, is that normal or underweight using KNN? And so we need to start by finding the nearest neighbors. And the way we're going to do that is Euclidean distance. I'm sure you guys are all familiar with the distance formula, but just to reiterate, it's the square root of the difference of the x coordinate squared plus the difference of the y coordinate squared. And so let's say x coordinates correspond to weight and y is height in this case. So that's how we're getting distance. So now we start by basically calculating the distance from our unknown data point, the 57 kilogram, 170 centimeter tall thing. And we basically find the distance from that point to every other point in our data set. So you can see on the left, there's actually the first 2 calculations are done for us. So we have, for the first data point, we have 170 is the question mark data points height, minus 167, which is the height of the first data points height squared, plus 57 is the weight of the unknown data point, minus 51 is the weight of the first data point. And so we take the square root of that and we get about 6.7. We do the same for the second data point. I'm going to keep doing that for the third, fourth, fifth, all the way to the 9th data point. And so now you can see under the 4th column right there, we have the Euclidean distance for all 9 of those data points. And we can see that we have k equals 3 in this case because square root of 9 is 3. So we're starting with k equals 3. And so now we have the k lowest, the k closest data points, which are data points 7, 8, and 9, because their distances are 1.4, 3, and 2, which are less than all the other distances. And so the total number of data points is actually 10. I forgot about the original data point. So 0 to 10 is about 3. So similar calculation, but we're picking 3 important data points here. So that's the more important. And so yeah, square root of 10 is about 3. So we're picking those 3 because they're the lowest ones. 1.4, 2, and 3 are less than all these other distances. And so going over it again, just in general, actually missed one part. You can see right here that these 3 are actually all normal. So we would classify this as a normal class. So yeah, we get normal in this case. We can do that for any new data points, assuming it has a weight and a height. And so a general recap of KNNs, we start with a labeled data set. We start with a bunch of data points with x and y coordinates or more coordinates, can be z coordinates and all, but we'll stick with x and y coordinates. And they all have a class that are all either stars or triangles or normal or underweight. And we also have a new sample data point that we don't actually know the class of, but we know the x and y coordinates does. So we know the weight and the height of that data point, but we don't actually know the class of it. And so we want to try to classify that data point using KNNs. And so from there, we select the k closest entries to our new sample. And we pick k by picking the square root of n, which is the total number of data points in our string. And so we pick the k closest entries, and based on which class has the most votes, we pick how we classify the data point as such, and yeah, classify it as that. And so from that, we have a new classification for our unknown class data point. All right, I'm going to turn it over to Ben to continue our Intro to Python tutorial from last week. Hope you guys enjoyed our KNN workshop.
Yeah, thank you. I just wanted to add a few last notes about KNNs. We don't have a slide on it, but I just wanted to talk about it because it's relevant to like next week's workshop. Some of the downsides of KNNs you might have noticed is that there's no real model to it. The model is just having all of the data and then basically comparing our new data point that we want to predict to all of the old data points. And so one of the downsides we mentioned was that it's computationally expensive. But another downside is also that it uses a lot of space because you have to store the entire data set with you. That's the other downside we talked about, where it works well when you have a small data set. And next week, what we're going to look at is linear regression. And essentially, we're simplifying the model, or we're building a model to, we're building a model that's more spatially and computationally efficient than the KNNs that we've seen here. But it also introduces some limitations in that earlier on in the workshop, now that I can share my screen. Sorry.
Also a quick answer to the question that Shrank asked in chat. Oh, Paymon's got it. But basically, it works best with 2 variables, but you can use it for more than 2 variables because you can calculate the distance in 3 space or 3 dimensions or 4 dimensions. Just add this difference term to the square root. But as you add more dimensions, you might have greater variability in your variables overall in distances. So it might be a bit less efficient overall. So like Paymon said in chat. But yeah, thanks for the question.
Yeah. But that was pretty much it. I just wanted to mention that KNNs is still relevant today because you can actually solve some difficult problems with it because the decision boundaries, meaning like at what how it classifies, like at which point it changes from like red to blue, or decides whether a point is red or blue. It doesn't have to be a linear line. You can actually match some pretty complex distributions here. So in some ways, KNNs can be more powerful than the models that we're going to look at later, which like linear and logistic regression. But in other ways, there are disadvantages to using KNN as well. Yeah, for those of you who wanted to continue last week's introduction to Python, we're going to continue right where we left off. So here is the link to the Google Colab. If you don't have it, I'm going to actually copy it and put it in the chat for you guys.
Well, I got a quick question about KNN.
Yeah, of course.
But can you, like, I know, I guess Payman kind of answered it, but you can't really assert certain weights to other dimensions, or like what dimension you want to put more weight to, but is there a way to do that? Because, I mean, it would be kind of simple if you just use Euclidean distance and Tygon.
You can definitely put weights to it. And I guess like the models that we're going to look at next week and the week after, like linear and logistic regression, that's kind of what we're doing. We're putting weights to each of these features. So like maybe for those of you who, so I just want to explain this for everyone else who's listening in. What we're talking about is like, let's say, let me actually go back to the cat example. I like that one. But let's say the sharpness of the claws, or actually let's say the length of the ears is not as important as the sharpness of the claws, because maybe some cats have long ears, some dogs have short ears. So that maybe like there's a lot of overlap between those two. You can weight, but if we're using just pure Euclidean distance, then the length of the ears is pretty much just as important as the sharpness of the claws. So the distance is based off both of those factors. But if we wanted to weight the length of the ears less than the sharpness of the claws, you could multiply like the distance, like the Euclidean distance would be like you subtract the difference between the y value and then squared, and the subtracted distance between the x and squared. But then you can also multiply that by a weight to reduce how much you weight that. So that is true. You can do that. So there's a lot of extensions to this, and there's also extensions to solve this problem too, right? Where you have a lot of outliers. You can intuitively look at this and say like, oh, well, blue is obviously an outlier because it's surrounded by green dots, and so there's an algorithm for that. I think it's called condensed nearest neighbors, to remove outliers and kind of simplify this decision boundary. Yeah, thanks for the question. That's a great question. Anything else before I move on to introduction to Python?
Could you explain like how this slides, like how the points are categorized into different color segments? I kind of understand like the KNN like basic intuition, but like I kind of confused like how this points are categorized into different colors.
Right. So all of these points are training data points. So this is like the data that we have before. And if we want to make a prediction, let's say we have a new point and it's here, right? Like where my cursor is. Can you see my cursor?
Yeah.
Okay, yeah. So if I have a new point here, then since it's in the blue section, then it's going to be classified as blue. So these boundaries, or like the background color, is like kind of that, like if a point lies on this background color, then it's categorized as that point. And the way we determine what background to color it as is based on the k nearest point. So this is k equals 1. So we're just looking at the nearest point. So at any point here, so we look at this point, the nearest point is red. And the nearest point is red all the way up until we reach this boundary. And that's where the nearest point is both either red or the blue point, right? So that's kind of the boundary. And if we go a little bit to the left, and then it becomes the closest point is the blue. Yeah, hopefully does that answer your question, or?
Sort of, but like I understand like what the boundary means, but like what does it make, like how does the value of k makes the difference in terms of
right.
the boundaries?
Yeah. Okay. Let me try to answer this on this side. Move some windows over. Okay, so the idea is this is k equals 5, right? So at this point, the 5 closest points is red, 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 and then green. So so we choose this one to be red. If we get closer to the boundary here, then the closest ones are going to be like green, red, red, right. Green, red, and red. And so this one is red. But in where you have a white region, so like right here, you can see that the closest 5 points would be this red one, this blue one, this green one, and then like this green one. So you have 2 green, 2 red, and 1 blue. And there's no one has a plurality, no one has a majority. So we don't classify it as any of them.
Oh, okay, I see.
Yeah.
Thank you.
Mm-hmm. Anyone else have any questions? If you have any questions later on, feel free to ask. And of course, that's the point of the Discord, is if you have like questions afterwards, you can always ask there like way after the workshop, or if you go back and review stuff. But yeah, so we're gonna go on to the Python review again. I know like about half of you answered that you guys already know Python, so that's pretty much what we're gonna go through it for the rest of the workshop. If you And again, it's not opening on Google Colab. One moment, sorry. Okay. It's just like, okay, there. I was worried it's not going to load again. So where do we leave off? I believe it was right around here. So we went over for loops last time, and we didn't go into while loops. Let's see. So with while loops, actually, let me start from the beginning of loop. Oh, no, that's a lot. I'll just continue with while loops. So while loops are similar to for loops, except instead of kind of putting all of the, instead of like specifying the start and end conditions right at the beginning, you only specify a single condition at the statement. So here we're saying that while end is less than or equal to 10, then run or execute these two instructions. So let's walk through the execution. This first line is a comment. The second line here will assign the variable end equal to with the value 1. And then when we go down here, we reach the while statement. And what this is going to do is it's going to check first, is end less than or equal to 10? Since the value of n at this point in time is 1, this statement is true. And if this statement is true, then it's going to execute these two statements. The first one is going to print out the value of n times 2. And then the next statement is going to increment n by 1. So it's going to take the value of n, which is currently 1, add 1 to it, so it's now 2, and assign that back to end. And then instead of continuing on, like if we had another line here where we do print done, what it's going to do is it's going to go back to the beginning and check this condition again. And now n is going to be equal to 2, and 2 is still less than or equal to 10, so it's going to execute these two statements again, and then go back to the beginning and check again, and so on and so forth. It's going to do this until at some point, because we're incrementing end by 1 each time, it's going to be n is going to equal to 11, right? And when n equals 11, this condition is false. And if this condition is false, it's not going to execute these two statements, and it's going to continue executing where it's not indented here. Again, indentation is really important in Python because it's how it determines like where these blocks of code are, these blocks of statements that are tied to this statement on top, this control statement. So if we execute this, what we're going to see is, run anyway. The first time you start run at any block, it's going to take a little time. But yeah, it's going to iterate from 1 all the way until it's 10 and print it the value multiplied by 2. So it's the multiples of 2, from 2, 4, 6, 8, all the way to 20. And then you can see at the very end it says done, because it exits this loop and continues executing. But it doesn't run done every single time because the done is not indented like the rest of these statements are. Another thing to note about this is because it's unlike a for loop, you can write while loops that don't terminate, because this condition doesn't necessarily have to be like this. Like if this statement is true forever, like if we didn't have this and n just remained the value 1 all the time, if we ran this, it just keeps running 2, 2, and it never ends. Let me go back, and you're just gonna have to stop it. Hopefully it's gonna let me stop it. There we go. Oh, that wasn't it. Yeah, it's not letting me stop it. Stop. Stop.
Infinite loop problems.
Yeah. Stop. There we go. All right.
General advice, don't write infinite loops unless you are intending to, because they can mess up your program a lot, like you saw there.
Yeah. So you just have to be careful about that. Make sure that your like exit condition is actually reachable. And did we not mention this earlier? Oh, we didn't. Okay. So another thing you can do is you can actually, there's another statement you can use called break. So what break does is if you reach this statement, it's going to always break out of the loop. So always exit the loop. So it's as if this condition was false. and it won't do anything afterwards. So like if I do print, you won't see this. Yeah. If you do that, then you notice that it goes here, it prints it once, and it breaks out of the loop. So it skips everything afterwards and goes down here to done. And you can do something like, since we introduced if statements last week, you can do like if n is less than 5, then we break out of the loop. And again, you have to indent it. You will see this now. And if we do this, then when we run it, oh wait, hold on. Wait. Am I doing something wrong?
If n greater than 5.
Oh. Greater. Oh yeah, it's breaking. Sorry.
Yeah, you don't want to break. Yeah.
Yeah,
No worries.
don't want to break. I'm sorry. I'm an idiot. I know how to. I'm a senior computer science. I know how to do this stuff. Don't worry. Right. So in this case, the condition is the opposite. The mistake I made was I assumed that it's running this while it's true. But if n is less than 5, which it is at the beginning, which is it's 1, it's going to execute break and it's going to break out of the loop. All right, let's move on. Forget my mistake. Talk about list comprehensions now. This is something that's kind of unique to Python. If you haven't used it before, if you used a different programming language, they might not have list comprehensions. But what's really cool about list comprehensions is that you can kind of, oh yeah, it's similar to set builder notation in math. So if you've done some math in the past, then this might be familiar to you, or not, because you got like statements like for. But we're sort of using the same syntax as the for loops, but it's a little different in that it's like an expression inside of a list that's delimited by these square brackets. So before we would define a list by just listing values within square brackets, right? A new way of doing this is to actually loop through something. So in this case, we're looping through our old list and we're changing the value. So for I in old lists, what this means is that it's going to assign I the value of each value in the old list one at a time. And each time it assigns that value, assigns a value to I, it's going to insert that value -1 into the new list. So if we run this, what we're going to see is that it takes old lists and subtracts 1 to each of the values. If we can also do something like this. So this is the input array range. It doesn't give you a list anymore, but for all intents and purposes, it acts like a list. So this is going to give you a list between 0 and 5, 0 and 5 not inclusive. So it's going to be 0, 1, 2, 3, 4. And what it's going to do here is this is a list comprehension. So it's going to iterate through that list. So 0, 1, 2, 3, 4. And for each of those values, it's going to insert the value 2 to the power of I into the output array. So in this case, it's going to be, the first one is going to be I equals 0. And 2 to the power of 0 is 1. I equals 1. 2 to the power of 1 is equals 2. And then you get the powers of 2. Yeah, it's really useful for creating lists. It's kind of what it's for. I don't know. Functions. Let's talk about functions. So I'm going to make comparisons to math because I think that's something we all have in common. A function in Python is similar to a function in math in that it takes in a certain one or more values and it returns one or more values. In this case, it always returns a single in this case, this is a function that takes a single value and returns that value multiplied by 3. So like in math notation, it would be something like f of x, f of x is equal to 3x, right? This would be kind of like that. But in Python, the way you define a function is you use this special word called def, like defined. And then the name of the function, again, unlike math, you can use an entire word. And the name of a variable, you can use a word. And you can return a value. And the body of the function is going to be indented. In this case, our body is just a single statement called return. This is another special word that's similar to break in that once you hit this statement, it's going to exit the function and return that value. So once you define a function, you notice that we don't get any output because this is just like defining a function in math. So it'd be like f of x is defined as 3x. We can use the function now like this. So you just use the name of the function and you pass it a real value, in this case 5. And when we do that, we get the value 15 back. So just like math. You can also define or assign it default value. So if you typically, if this value has something default, like, actually, let me make this something a little bit more interesting. Let's say we have a function called power, and what it does is it takes a number, a base, and brings it to the power of to a certain power, right? And what it's going to do is going to take that base and raise it to that power. If, for example, we're doing a lot of computer science and we use binary a lot or something, I don't know. Or basically our base is typically 2, then we can assign it a default value like this. And what happens is when we use this function, if you assign a default value, it has to be at the end of the list of parameters. Like that. So we could use this like normal, right? We can say the base is equal to 10 and the power is equal to 3, right? And then if we do this, then we get 1,000, right? So 10 to the power of 3 is 1,000. But because we assigned base a default value, we can actually leave out that parameter. And if we leave out that parameter, it's going to assume that default of 2 and raise 2 to the power of 3. Oh, I don't think I talked about this. You can also specify, oh yeah, that's the next line. You can specify the parameter name, not just by the order. Like in math, you would normally do something like, if you had a function with multiple values, it would be like 3, 4, 5. And it just be separated by commas. You can do the same thing here. So in this case, this would be like 3, 10. And so you can see by the suggestion here, it says that the first argument is going to be power, and the second argument is going to be base. And if we do this, we get 1,000 like we expect. But you can also specify the value more explicitly. You can actually say, I want to assign the parameter called value the value to. And yeah, that works as well. And you notice here, when I did that, you can actually do it out of order. You don't have to keep the same order, power and then base. You can do base first and then power. This only works if you do it, if you specify the name of the parameter you're assigning it to. Because if you don't do that, then it just assumes that it goes in the order that it was defined. Yeah. Does anyone have any questions? If you do, feel free to interrupt me, like unmute yourself, or you can like type in chat. I have it open on the left side so I can see it. Right. And there's some more, and there's some extra problems, if you have some practice problems just for basic Python in this worksheet, I believe. So I don't want to copy this, so I just want to copy this. Yeah, I believe it's not going to open in Google Colab, is it? Yeah. No. Okay. It's not opening in Google Colab. Why is it not doing that anymore? I swear I tested this earlier today. Okay, this opens in Google Colab, so I'm going to share this link. Oh, that's a solution link. You don't want that. Hold on. I don't know actually how to open with Google. Okay, you're going to... here. Okay, so now it says I can open in Google Colab. All right, but is this the same link? It is, I think. No, it's not. Okay, I'm gonna change the link. If I save this, and now if you guys refresh this link, the one that that's in the chat, let me make sure that actually goes to the right one. No, oh my god, that's the wrong link. No. All right, now that's the right link. I'm sorry if you guys were trying to open that and couldn't follow along. But this is the right link now. And this is the link to the extra problems. Yeah. So I believe there's solutions to it too. I'm just going to share it because I feel like if you guys want to cheat, why not? Sure. You're just hurting yourself, I guess. But yeah, those are the solutions to it if you want to check your answers afterwards. They're just practicing the stuff that we showed here. And you can also look up tutorials for Python elsewhere. And there's a lot of help out there. If you want more specific suggestions, you can ask like in Discord later, maybe. And I can try to find some better examples. But yeah, now we're just going to go through some advanced stuff. Lambda functions. Yeah, so this is another way of defining a function. I feel like we didn't go over enough about functions. I want to talk a little bit more about functions because that's useful. I'm gonna add another text box here. Functions don't have to be a single line like this, right? You can act like in math you would have you can have an expression that's longer, but it's still just like one expression. In Python, because we execute from like left to right, top to bottom, you can do a lot more in a function. So if we have a function like do stuff and take in like x and y, we can combine this with the stuff we learned above and do something like for I in range x, I don't know, y plus equal 5. Right, and so what this is going to do, if we run this, so we have more stuff in this. But yeah, we also have to return the value y. So this function is going to do a little bit more than the ones we have up here. We're kind of combining what we learned about for loops and what we learned about functions to do this. So this function. I can't find the person who's. Oh yeah, no, they muted themselves. Thanks. Right. So do stuff does a little bit more. Can anyone kind of tell me what it's doing? Besides like just describing it, or like what is it actually? Yeah, like what is this value? All right. Is there anyone in chat? No. I just kind of describe it. So if we walk through it, it's iterating through x. So when we say range, oh yeah, if you hover over it, it tells you range is going to be like a list that's between 0 and x, not including x. So in this case, we set x is equal to 5. So it's going to iterate through 0, 1, 2, 3, 4, 1, 2, 3, 4. But it doesn't actually use the value I. That just specifies like how many times it's going to do it. So when we do that, it's going to iterate through. It's going to run this statement 5 times. So it's going to add 5 to y 5 times. So it's really just adding y plus 5 times 5, which is 25. Right. I don't know. I thought that was important to mention because up until this point, we've only shown functions that have a single line in them, like math. So you can combine this with all the other stuff we've seen before. Yeah, Lambda expressions are. I think it's more intuitive if you just like have a math background, because with Lambda expressions it's just like this is f, right, and then, or not f, but like this is the input, and the output is going to be the input multiplied by 3, and you could say like f is equal to that, right? And so if we do this and we add a new line of code, you can say f of 3 is going to be 9. So this is like f of x is equal to, f of x is equal to x times 3. Yeah, so you can only use a single line here, unlike the defining a function like this, where you can just have like a whole body of instructions. Here you just have a single expression that's your output. Map and filter methods. You really don't need to know this. Yeah, I guess we could talk about it. So the map function, what it does is it takes a function and a list and applies the function to every element of that list. So it's sort of like that list comprehension that we showed earlier, but it's kind of combining it with our functions. So it's exactly as this line describes. We can start with a list or any kind of collection, I think, and you can. It just applies the function to each element of the list. The reason we do a list on the outside is that we're converting it to a list. So if we just do this by itself, the type of this object is map. Oh yeah, Nikhil also mentioned you can think of it x is equal to x plus x is 3x. Yeah. But if you turn it into a list, it kind of expands it. Yeah, and this is combining it with like a lambda function. So the thing that's nice about using lambda functions like this instead of defining functions like this is that when you define a function like this, you have to indent and you have to have that return statement. And so you can't kind of fit it into, it's not an expression, you can't fit it into a single line like this. So if you only need to use the function once and you don't even need to like declare a name, define a name for it, and do all of this stuff, you can use a lambda function. So this is kind of, I think another term for it is like an anonymous function. It doesn't have a name. It's useful when you're combining with methods like map here. Yeah, so doubled list does what it says on the tin. It doubles each of the elements, element wise on the list. The reason I don't think this is very useful is because, like it said up here, it's if you're not using NumPy, but we're pretty much always going to use NumPy. So the command first converts a list to a map to apply a function. Yes. Okay. I should clarify. Thank you for talking about that. Are you asking about this one right here, Jeffrey? Yeah. Okay. So the way you should read this is from the innermost parentheses to the outermost parentheses. So map is what executes first. My list is already defined up here. So my list was already a list when we started with. We didn't convert it to anything, but we pass it as an argument to the function called map. And the function map takes in another function and a list. And what it does is it just applies that function to each element of that list. And the output of map is a map object. So we don't want a map object, we want a list back. So that's what the outer function does. So what list does is, list is a function that takes in some kind of object like a map object and returns the list. The reason why it doesn't just return a list directly is because it kind of executes lazily, I think. It doesn't actually convert it to a list until you actually need it to be a list. And so what this outer function does is basically telling us, I want it to be a list right now and not later on somewhere. So if you want, you could chain a lot of functions together and they won't like all execute. They kind of execute once you actually need the values. I hope that explanation makes sense. I didn't want to get into too much detail, but yeah. I'm glad it was helpful. Yeah, I'm ask any questions because I don't know. I might gloss over something that. How is this similar to NumPy? Have you used NumPy before, Mila? Or yes, okay. How is this similar to NumPy? There are functions in NumPy to kind of do the same thing, but in NumPy, like if you have an array. Anyone who's not familiar with NumPy yet, we're gonna have like a workshop that going over this stuff, so you don't have to worry about it right now. But to answer your question, if you do an operation to an array, then it does it element-wise, so you don't really need to do this. Like if you wanted to double an array, a NumPy array, like multiply each element by 2, you could just multiply it by 2. So you don't actually need map. But if you wanted to do a more complicated function, I think there's like NumPy map. Yeah, I looked at this before. So this guy kind of like looked at how efficient each of these methods are. And I didn't see his conclusion. But yeah, vectorizes would be the equivalent, I guess. You could also, so this is, okay. This won't work with everything, but like if you're doing simple operations, you can just apply that operation to an NumPy array and it's gonna automatically kind of map it to each element. Is kind of what they're saying. But like if you did something more complicated here, that might not always work. Oh yeah, thanks. Yeah, if there's any other questions, I think there's also some other useful built-in methods that you can just kind of read through them. There's not much explanation needed. So if you have like a string, you can convert the characters to lowercase. You can convert it to uppercase. You can split the string into 2 strings based off of something. So it takes a string hello world and splits it into 2 strings hello and world at this element, like comma space comma. But you notice that it actually includes the space here in world because it just removes the comma and splits it into 2. You can actually, it doesn't have to be a single character here. It can be like a string, and then it will do it'll take this string and then remove that and split it into 2. And this one, yeah, this one removes the last element of the list and returns it. So if you're gonna just pop it off. This is more for like computer science, like if you're doing a stack or something. Yeah, and then you notice that the last element is gone. Yeah, that's it. It's pretty much all the things that we wanted to go over. This is enough, I think, to go on to, well, like when we get into the more hands-on workshops, this should be enough information. But otherwise, yeah. Please fill out our feedback form. If you have any, if you thought this was like terrible or it wasn't useful, let us know. If you thought, whatever you thought was useful, if there are any parts of it that you really liked about the workshop, please let us know about that too, so that we know what we need to change, what we need to remove or add. And this is not today's event code. That's Los Angeles. And this is the Facebook group if you want to find out about future workshops, and the GitHub if you want the code, which we don't have any yet. Yeah, that's pretty much it. This is not the feedback form link.
Yeah, links in chat, guys. But thank you guys for coming.
Yeah.
Please fill out the form before you guys leave if you can. It really helps us a lot.
Yeah, thanks for coming.
Thanks, guys.